Welcome to this episode of Mr. Lehman's Knowledge Explosion. In Lesson 2 of Unit 4, we want to focus our energy on proving triangles are congruent using 4 ideas. Now before we get into those 4 ideas, we need to review what congruent triangles means. The definition of congruent triangles means all 6 parts of a triangle are exactly the same or congruent to the corresponding 6 parts of another triangle. So I've given you an example of what we have is a congruency statement. Simply saying triangle XWY, so from X to W to Y, so that top triangle is congruent to triangle YZX, or the bottom triangle. Now it's important that that congruency statement goes in order. Remember, we now know which parts match up. Side XW, the first 2 letters, is congruent to side YZ, the first 2 letters in the second triangle. So I can mark that. XW should be the same as YZ. I also know that WY is congruent to ZX because those are the second letters in each part of the congruency statement. So I could mark WY the same as XZ. And then the first letter X and the last letter Y should be the same as the first letter Y and the last letter X, which makes sense. XY and YX are the same way to name the same segment, or we could think of it as the reflexive property says those two have to be the same. Now some of you may be tempted to just look at the picture and mark that, but it's the congruency statement that tells me what matches up. Now those are the 3 sides that match up on the triangle. Remember, there are 6 parts. So I can also go through and mark the angles. So I could say angle X is the first letter, should be congruent to angle Y. And the second letter, angle W, is congruent to angle Z. And angle Y is congruent to angle X. Again, last letter compared to last letter. Now I can mark this. Angle W is the same as angle Z. But here we run into our first problem. The first statement I wrote, angle X congruent to angle Y, is exactly the same thing as angle Y is congruent to angle X, but they're referring to different things. So we should use 3 letters. So the first angle X in the triangle would actually be angle W to X to Y, and that will be congruent to, we want to use 3 letters, this angle over here, angle Y in the other triangle, which we could say angle XYZ. And then I want to do the same thing, I'll do it in a different color here. Angle Y in the top triangle has to match angle X in the bottom triangle. But again, I can't just use X and Y because there's more than one angle X in the picture, so I should use 3 letters. I'm going to say angle WYX is congruent to angle YXZ. And now I have all 6 parts, 1 pair of sides, second pair of sides, third pair of sides, congruent, and a 1 pair of angles, second pair of angles, and a third pair of angles. So that's what congruent triangles means. All 6 parts are the same. What we're trying to do is think back to the activity we did last time when we said, how could my lazy friend Bino just prove triangles are congruent using 3 things instead of showing that all 6 things match? And what we came up with was, if 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle, then the triangles have to be congruent because you can't change the angles. So if you have 1, 2, 3 sides matching 1, 2, 3 sides, no matter how the triangle is shifted or rotated or moved, those 2 triangles have to be the same. So we would say these are congruent by side, side, side. And if you see those markings on any other triangles, you can say the same thing. A second idea we have is called the side angle side postulate that says if 2 sides and the included angle of one triangle are congruent to the 2 sides and included angle of another, then they're congruent. So if you look at these, they're a very specific order. It has to be side 1 and side 2, and the angle that connects those 2 sides has to match up side 1 and side 2 and the angle that matches or connects those 2 together. So if you look at it, it's a side followed by an angle followed by a side in that order, matching a side followed by an angle followed by a side. So two sides and an angle is good enough if it's in that relationship. It's also good to have two angles in one side if it's an angle-side-angle relationship. And again, it must go in that order. So if two angles in the included side, included simply means the side that connects the two angles. So if it goes an angle, included side, and then an angle, matching an angle, an included side, and an angle, then those three things are good enough to guarantee me that these triangles are the same. Likewise, we could have the two angles and then the side. So if I have an angle, I skip this side, and then I have another angle and a side, and I have the same relationship over here, an angle, skip that side, an angle, and a side. There's no possible way to have those three things the same and not have the triangles be congruent. So we would say if those two things have an angle-angle-side relationship, those two triangles are congruent. So these are the four ways we can prove triangles congruent without having to show all six the same. So what I want to show you are some examples on how we use that. But before we do, I want to make sure you understand this idea of included angle. For example, if I'm looking at side AB and I'm looking at side CB, the included angle is the angle that would connect those two sides, which in this case would be angle ABC. So if I was doing a side angle side, I would say side, then the angle, then the side, because the angle has to be included. So make sure you understand that idea of included angle. Now the reason we're interested in the included angle is because that's the only way for side angle side to work. So if you're going to use side angle side, you have to make sure you understand the idea of included angle. So what we're going to try and do is determine if these triangles down here are congruent. So determine if there is enough information to prove them congruent. If yes, state the postulate or theorem that would prove them congruent. So we're going to be looking for angles and sides that match up. Here's why we work with parallel. You have to find them. So I noticed that I have some parallel lines in this picture. So I'm going to use those to say that angle ABC is congruent to angle DCB because they're alternate interior. So what I see right now is I have one side and an angle matching a side and an angle. So I've got to figure out if I have any more angles or sides that match up. Now the parallel lines are only on the top and bottom, so I can't mark these alternate interior angles because AC and BD aren't parallel. But here's where the reflexive starts to come in handy. CB is overlapped in both triangles, and if you're not seeing both triangles, let me color them in for you. We're looking at triangle ABC at the top, and we're looking at triangle BCD on the bottom. And what we have is a side and an angle and a second side matching a side, an angle, and that side. So I could say these two triangles are congruent, so I'll make a congruency statement that says triangle ABC is congruent to triangle. Now be careful, I started with A, which was unmarked, to my marked angle to my reflexive side, which would be triangle D, unmarked to my marked of C to the side B. And I would say they're congruent because of a side-angle-side relationship. And that's what you're going to practice, that's what you're going to try and do. So let's do another one, number 5. If these markings are correct, I've got a side and an angle already matching a given side, and an angle. So you may be tempted to say, oh, that's a side angle side because I see side, angle, and side. But here's the problem. Side angle side only works if the angle is included, and the included angle between those two sides would be angle M and angle R in the other triangle. So side angle side is out. So sometimes you can treat this like a checklist. Side angle side's not going to work. We could say side, side, but I don't know if side NP and side PQ are the same. And I'm looking for some way to say that they are, a midpoint maybe, or a bisect. I'm not seeing any reason to say that they are, so that means I can't say the three sides match the other three sides. I could maybe do an angle side angle, but I don't see any parallel lines or any bisect or vertical angles here, so I'm not seeing any way to say any other angles match. You might be tempted to say you've got some vertical here, but that's not vertical. They have to go all the way through. So I'm not seeing any second pair of angles, and same thing for angle, angle, side. I only know the one pair of angles. I don't know a second one. So I'm saying there's none of those four theorems that are going to work. So I'm going to say these two triangles are not necessarily congruent. And that's how we're going to use these theorems. So what I like to see, like in example number 6, is parallel lines. So there's more than one way I can do this. I notice right away that WY is a transversal that creates angle W and angle Y along the parallel lines, so those are the same. But I also noticed that angle WZV is vertical to XZY. So if I look at this, I've got an angle and a side matching an angle and a side. So these two triangles are congruent by angle, angle, side. But what if somebody else came along and did this exact same picture, but they saw these things? They said, yeah, I see your vertical angles there at WZV and XZY, but I was looking at the transversal that went from X to V. And I was thinking that angle X was alternate interior to angle V. Yep, you're right, that's true. But that would give me an angle followed by a side followed by an angle that matches an angle followed by a side followed by an angle. So I'm saying that this would be an angle side angle. And I would say you're both right, because you used the parallel lines to prove the angles, and then depending on which angles you marked would verify which theorem you could use. So it's all about the order that the angles and the sides come in depending on which theorem you use. So either of these would be acceptable responses depending on how you justify your answer. So let's see how this would look like in a proof. In the proof down here in the bottom, we have our given information that AB is congruent to CD, and AB is also parallel to CD, and that's been marked on my picture and it was given to me. My job is to prove that triangle ABC, so the triangle on the left, is congruent to triangle CDA, the triangle on the right. To do that, I have four ways. It could be an angle side angle, a side side side, a side angle side, or an angle angle side. So I'm simply going to start looking for angles. I already see that I have one set of sides that are the same. I'm seeing angle 1 and angle 2 marked here, and I see them next to the parallel lines. Those are alternate interior. So angle 1 is congruent to angle 2 because if my lines are parallel, then my alternate interior angles are congruent. And I now have a pair of angles as well. So I'm probably not going to be looking at side, side, side because I already have a pair of angles. So I'm going to look at the other three. If I find another angle, I might have angle, angle, side. What I'm seeing is that, again, anytime triangles overlap, that side AC that they both share is going to be congruent to itself, but that counts as a congruent set of sides. AC is congruent to AC because both triangles use it. We would simply say it's reflexive to itself. It can't change. So now I have another side. So again, pay attention to the order. We had a side, an included angle, and then another side matching a same side, same included angle, and the same side. So I've got enough information now to say, yep, my triangle ABC is congruent to triangle CDA because of a side-angle-side relationship.